All right, so we're going to take a look at investigation 4.4. What we're going to do is we're going to find the type of relationship, explain why it's that type of relationship, and get the equation. It may not be in that order, but that is what we're going to do. So let's take a look at that first one. The first one says, a cylinder has a height of 16 inches. Consider the relationship between volume and radius of the cylinder. And so I know that a cylinder has a very specific equation, so I'm just going to go ahead and write that in the equation and then take a look at it. So we know that volume, that's not what I want, we know that volume is equal to the area of the base, which is pi r, see, that's how it's going to be, pi r squared times the height. In this case, the height is 16. And so, there we go, 2, that's what I want. So it's time to look at the equation and see if it gives us any clues on the type of relationship. Well, the first thing I notice about this equation is that it has a squared in it. And if we have a relationship where the highest degree is squared, we know that that is a quadratic relationship. Because it's not exponential, because exponential relationships have a variable x as the exponent. So we know this is quadratic. In terms of solving it, or giving a question, I guess I will go there. What is the volume of a cylinder with a base radius of 1 and a height of 16? Well, you do 1 squared, which is 1 times 3.14 times 16. And that's it. All right, next one. A rectangle has an area of 24 square inches, and consider the relationship between width and length of the rectangle. Well, I know that the area of a rectangle is going to be equal to length times width. In this case, we know 24 is equal to length times width, or LW. What type of relationship has x and y being multiplied together to have a constant product? And that is inverse. And an inverse relationship, again, is written as x times y is equal to k being the constant. But it is most often written as k over x is equal to y. And that makes a whole lot of sense, because if let's say I have a length of 2. If I have a length of 2, what's my width? Well, I'd say 24 divided by 2 is 12. All right, 3. A laptop costs $800, and it loses its value every, I'm going to scoot this down, every year, 50% of its value every year. And consider the relationship between the value of the laptop and the time. Well, I know that after when it comes out, it's worth $800. Then at year one, it's going to be worth $400. So I'm going to make a little quick table right here just for fun. So first, at year 0, it's $800. At year 1, it's $400. After 2 years, it's going to be worth $200. So what am I doing to go from here to here? Well, I'm multiplying by 1/2. You're probably saying divide by 2, but I say multiply by 1/2. So what type of relationship multiplies by a constant value every time? Well, that's the definition of an exponential relationship. So we have an exponential relation. And exponential relationships are written as y is equal to a times b to the x power, where a is the initial value, that would be 800, and b is the growth factor or decay factor, in this case, and that's what you multiply by, in this case, 1/2. All right. Come on, there you go. Of course, now my scroll bar is hidden. So I'm going to erase this. I'm going to move this up so I can get to 4 and 5. There we go. All right, 4. Tim sells magazines for a fundraiser. His first customer buys 2 magazines. So this sounds like the job for a table. So 1 customer, so that's customers, magazines, 2 magazines. And next it says his second customer, 4 magazines. Then his fourth customer has 8, and his 8th customer, 16. Well, that's sort of funny. At first you're going to think 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. But wait, notice how the change in my x value, my independent variable, is not constant. So if I look at my changes, 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. I have a slope. I'm adding 2 every time, aren't I? And so if I'm adding 2 every time, that means it's a linear relationship in the form of y equals mx plus b. So y is equal to my slope of 2x plus b. And in this case, if I work backwards, at 0 customers, I'll have 0 magazines. So y is equal to 2x, and that's it. All right, a cylinder has a radius of 4 inches. Consider the relationship between volume and the height of the cylinder. A cylinder has a cylinder has a radius of 4 inches. And is it going to change? No. So we know that volume is equal to pi r squared h. In this case, we have v is equal to pi times 4 squared times the height. 4 squared is 16. So we have v is equal to pi times 16 times h. Oh. So once I do this little bit of simplification, do I have a squared here? I do not. That means this is also linear, because I have no other exponents and I'm not dividing by a variable. All right, moving on to the next page. And we're thinking. All right. Jorge keeps track of the number of people who visit his new website each day. On the first day, he has 3 visitors. This sounds like the job for a table. Day and visitors. First day, he had 3 visitors. On the second day, he had 27 visitors. On the third day, he had 81 days. So obviously, this is going up by 1. What did I do from 3 to 27? What mathematical operation did? Well, I multiplied by 9. Let's see if I did that again. 27 times 9 is... What is 27 times 9? Let's figure it out. Sorry about that dramatic pause. So we have 81 on the floor. 81 divided by, that's 3. And 3 times 3 is 9. So here we multiplied by 3. That's what I thought. That is a little different. Let's see what else it says. Oh my goodness, it said on the 4th day. It's not on the 3rd. I screwed up. I messed up. Sorry for saying. I missed this sentence. I'm glad I had that pause because I had made a mistake, clearly. So it went 9, 27, 81. So what am I doing each time? I'm actually multiplying by 3 each time. When you multiply by the same number every time, that is an exponential relationship. And if we stay with a times b to the x power, a is my initial value. So I'd actually have to go back to day 0. And if I follow a pattern, what do I do to 81 to get 27? I divide it by 3. What do I do to 27 to get 9? Divided by 3. What do I do to 9 to get 3? Divide by 3. What will I do here to go here? Well, I will have to work backwards and divide by 3. 3 divided by 3 is 1, so I have y is equal to 1 times my growth factor to the x power. All right, sorry about that. It's number 7. Unit squares are arranged by as shown below. Figure 1 has 1 rectangle. Figure 2 has 3. Figure 6 has 6, and so on. Consider the relationship between the number of rectangles and the figure number. Again, this is looking right for a table, because it gives us a sequence of events, and we need to track them. So figure 1, let's see if I can read it fully. So this is figure number, and we'll go with squares. So figure 1 has 1. Figure 2 has 3. Figure 3 has 6. All right, so let's go through the list and see if we can't figure out what's going on. So, and I'm going to slide this up a little bit so I can see the beautiful drawing. Oh man, that is a thing of beauty. Look at that. All right, so So what did I do from here to here? Well, I added 2, right? Or I could have said multiplied by 3. What did I do from here to here? I either added 3 or multiplied by 2. But that multiplied by 3, multiplied by 2, it's not linear, it's not exponential. Well, what's the difference from here to here? Well, the difference is 1. So I'm willing to bet the next one's going to be 4. It means 10. Aha. This is, you know what this is? This is a triangular number pattern, just like the one we studied in frogs, fleas, and painted cubes. Would you believe that? And that means that we have a constant difference here. That is a quadratic. And a triangular number, excuse me, I'm about to yawn. Triangular number equation is going to be written as y is equal to, and it's either going to be n times n plus 1 divided by 2, or y is equal to n times n minus 1 divided by 2. So let's take a look at this. So 1 plus 1, I'm looking at this top equation, 1 plus 1 is 2. So 2 times 1 is 2, divided by 2 is 1. 2 plus 1 is 3. 3 times 2 is 6. 6 divided by 2 is 3. So here's my equation. I can forgive you for not remembering this. That's the way it goes. And for our last one, a basketball manufacturer needs to know the relationship between the volume of the ball and its radius. Consider the relationship of volume and of the radius of a sphere. So you know that the volume of a sphere is equal to 4/3 pi r cubed. Okay. Because we have a cubed, we can eliminate right now. This is not linear, because linear equations don't have any exponents. It is not exponential, because exponential relations have a variable x as the exponent. And we also know that it's not inverse, because they're not dividing by a variable. So could it be quadratic? Let me think. Well, a quadratic relationship in its expanded form has a squared term. Does this have a squared term? It doesn't. It has a term to the third power. Therefore, this is none of the above, or it is not any of the relationships that we've talked about in this class, because it has to the third power.